Hello, I'm Aaryan Saygaonkar, and today I'm going to present a presentation on the topic of IoT-based home automation system. Now, this is a project that I have created for an internship based on IoT itself, and that was for a company called Emertxe Technologies. I'm from Thakur College of Engineering and Technology, third year, and for this project, I got the guide for this project was Jayalakshmi and Dhanya. Moving on to the contents that we will be discussing in this presentation. First of all, starting with the introduction, moving on to C programming, then Internet of Things, then embedded systems, Arduino, home automation project, and finally the conclusion. Whatever topics that will be discussed in this presentation were taught and implemented throughout the course of 4 weeks of the internship. Starting off with the introduction, Emertxe internship on Internet of Things was a 4 weeks internship that was offered and was available for me through my college. Now, there were several topics related to IoT that were taught from the basics to create a foundation for future projects, and all of these topics that we had studied during these 4 weeks we have applied on a final project. There were quizzes that were conducted throughout the 4 weeks based on each of the topic that was taught to us by the guides and mentors. For example, there were quizzes conducted on C programming, the quizzes conducted on Arduino microcontroller, and there were some even conducted on IoT. There was a development of a project along with the mentor to address the requirements of home automation. Now we'll discuss what are these requirements and how they were addressed in the future slides. Moving on to C programming that was taught in the first week of internship. Now, C is a general purpose programming language created by Dennis Ritchie at the Bell Laboratories in 1972. A C program is divided into 6 sections. There is documentation, link, definition, global declaration, main, functions, and subprograms. Here I have provided two images to understand what C programming is. The above image demonstrates how the C programming structure goes about, including the functioning of how it is during its editor and finally when you are executing the program. There are 6 steps that the C programming structure follows from when the programmer includes his source code to when it is finally executed. In the editor or the IDE that you use for C programming, you write your source code and that is saved with .c extension. Even header files are written in this editor or IDE. Now, this is a high level language and needs to be converted into the machine level language. To do so, first off, you start off with a preprocessor that includes all the files that you had mentioned during your C programming. These files are replaced with the actual library functionalities that these files include. Then comes the compiler. Compiler converts your high level language into the object code. Then the linker is used to connect all the libraries that you have mentioned in your C program and convert the object code into the executable code. The loader is then used to take this executable code with along with all these libraries and connect it to the CPU for execution. I have provided also an image for the basic structure of C program. Here, as you can see, hash include stdio.h is a preprocessor directive. As mentioned before, it after you include your source code, this is fed to the compiler and it replaces all these files. Like for example, std.io is a header file that you include, and the preprocessor helps you to transfer all the data present in that file in your code. Int main is the main function of your program. Whatever functionality that starts with your program starts with this main function. Int declaration means that this main function returns a value that is of integer type. Now here we have added a comment to display hello world. This is a comment that generally does not take part in the program but is just used to clarify or show to the user or the person viewing the code what is happening. Printf function allows you to print whatever text you want on the screen, and \n is just used to put the cursor on the next line. And return 0 has to be mentioned since you have declared at the start of the main function returns an integer value. Moving on to what we have studied in C programming during the first week, there were many topics that were discussed and also demonstrated to us through programs which we solved along with MAM. Now, I'll mention the topics that were discussed during the internship related to specifically C programming. Starting off with the number systems, since the number system is an important value to whatever we are coding and whatever projects we use, there were 4 number systems that we discussed. That was decimal, hexadecimal, octal, and binary. Moving on from number system, we were introduced to data types that are generally used to declare whatever variables or methods that we use in our programs and codes. The data types that we discussed were char, int, float, and double. There are modifiers for these data types like short, long, signed, or unsigned. There are qualifiers like constant or volatile, that means the value changes or does not change at all. The syntax and semantics of C programming as to whether the semicolon should apply or what rules are used when you're programming in C. Conditional constructs, this is the main part where our actual coding had begun, where we studied conditional statements like if, else, switch, etc., and loops such as for, while, or do while. Now, operators are used to perform operations in your code, whether they are arithmetic, logical, relational, bitwise, or even assignment operators of normal equal to. Then we started going into data structures, where we came across arrays, and arrays are used to store values of the similar data type. Moving forward, we also studied about the pointers. Pointers are used to point the variable to the value stored at a specific location and access the location itself or the value as per your need. Then we studied the functions. As mentioned before, the main function is the default function, but you can even define your own functions for performing separate tasks. Now there are two ways you can call these functions and pass whatever values you want. One is pass by value and pass by reference. Pass by value just passes a copy of the value that you want to send to the function, but pass by reference sends the actual location of the value where it is stored. Whatever changes you do to the value through pass by reference is made actual changes to the whatever functional values you want. Then come the strings. Strings are like an array of characters. Now, strings can be any form of words and are stored in double quotes. Then were storage classes, and finally there were preprocessors. That is the header files and macros. Now, header files and macros that we will be using in the future will be used for defining several of our specific tasks. And header files will be used to define or declare whatever values and variables that we will be using. And macros are generally used to replace the code or a text line where it is called with an actual amount of code lines that was stored in a macro. For example, it is a function that is not necessarily present in the code, but when you call it, it replaces that code with whatever lines of codes that you wanted to access. This was all for the C programming. Now we were going into the actual core of our internship, that is the Internet of Things. Now, what is Internet of Things? Internet of Things is actually an internet of all the devices that connect through the internet, and they exchange data or any kind of resources for performing specific applications or just for increasing the database. What is an IoT device? It's a physical object that connects to the internet. It can be a fitness tracker, a thermostat, a lock, or appliance, even a light bulb. Now imagine shoes that track your heartbeat and can flag potential health problems. You don't have to imagine because these smart shoes already exist. A most common device that can be demonstrated as an IoT device would be a smartwatch that you see people wearing from time to time. There are several applications of IoT, like the IoT is used for creating better enterprise solutions, integrating smarter homes, which we will actually be demonstrating through a project in the future. Innovating agriculture, like it can be used for checking the quality of ripening of a particular fruit or vegetable. Building smarter cities by connecting different places through internet. Upgrading supply chain management, where each part of the supply chain or even inventory line management or even it can be used for warehouse management. And finally, transforming health. As you know, during COVID, there were many IoT devices that had been applied in the field, and commoners were using these IoT devices instead of going to the actual physical hospitals. These IoT devices help connect people to the doctors with ease. Moving on to the embedded systems. An embedded system is a computer system, a combination of a computer processor, computer memory, and input or output with peripheral devices that has a dedicated function within a larger mechanical or electronic system. In short, what embedded systems mean is that it is a combination of hardware and software together. There are several applications of embedded systems. It can be used in motion sensors, manufacturing equipment, domestic appliances that you see in every day, like washing machines, etc., audiovisual equipment, gaming console, telecommunication equipment, medical devices, and even your cars and vehicles. Now, the structure of embedded systems is demonstrated through this block diagram that I have put up. Starting with the sensors to analog to digital converter, it is also connected to the memory, and this analog to digital converter transforms whatever data that you are sending to it through to a processor and ASIC. ASIC is application specific integrated circuit, and now this is also connected to the memory. Now, whatever resources or data that you find in the processor is again converted from digital to analog, and it is transferred to the actuator. Actuators are the final part of your device that implement whatever you want in the real world. Actuators are like the arms of your robot, which do the functioning that whatever is sensed through your sensors. Now let's go on to Arduino. Arduino is a microcontroller that we have actually used for our project. Arduino is an open source platform used for building electronic projects. Arduino consists of both a physical programmable circuit board, often referred to as a microcontroller, and a piece of software, or ID, integrated development environment. Now, Arduino has 14 digital input or output pins. Six can be used as PWM outputs, six analog input-output pins, a 16 megahertz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. Now, for our project specifically, we have used the Arduino Uno board, and that can be programmed using various IDEs, and we use the Arduino IDE for this project. As you can see, I have provided an image for Arduino Uno. Now this board, we have not actually used a physical board for our project. We have used a simulation, which I will be demonstrating further. There are several applications of Arduino, and these applications are in various domains of our society. They are applied in system design, general purpose applications, healthcare, education, mining, home automation, smart agriculture, defense, etc. The part of a domain that we will be applying Arduino for is home automation, as I had mentioned before. Moving on to the actual project of our presentation, home automation project. The home automation project was created to automate any kind of functionality in your home that you generally need to actually physically make changes to make the task occur. Now there were several requirements of this project, like software specification requirements. Now these requirements were declared at the beginning of a project, so we understand what we are going to do throughout the project and see to it that these requirements are met by the end of the project development. Starting off with the first requirement, that is the garden lights control. In your house, there are different garden lights that you have to physically go and switch on and off. Wouldn't it be better if you would be able to automate the switch on and switch off process of garden lights based on the light detection that is there in the environment? For this, we have used an LDR sensor. Now, the LDR sensor is used to detect light, and with the help of this, we check if the LDR sensor detects there is light outside, it won't switch on the LED. If it notices that there is no light outside, it will switch on the LED. Now I'll read out whatever specifications were mentioned. That is, read the read the LDR sensor value. Based on the reading from the LDR, vary the brightness of the LED, which represents controlling garden lights based on the availability of sunlight. Now the Arduino Uno board forms as the bridge between the LDR sensor and the lights, where we connect the Arduino Uno board to the LDR sensor. The LDR sensor provides the input, and the Arduino Uno board instructs the lights to vary their output. Moving on to the second requirement of our project, that is the temperature control system. Now, for this, what we were thinking of applying to is that we could be able to control the temperature of a house, where the general temperature, if it is very low, you can switch on the heater, and it will increase the temperature of the house. And if the temperature is very high, it will switch on the cooler, and it will decrease the temperature of the house. To automate this process, we have used a temperature sensor, that is the LM35 temperature sensor, and the values of what it is controlling is displayed on the CLCD output screen. For using this, we have used an application, that is a Blink IoT application. Blink IoT application is used to provide an interface for human interaction, where the humans can control the heater or the cooler and see how much is the output of the temperature. Now for temperature control system, we have read the temperature from the temperature sensor and display it on the CLCD, control the temperature of the system by turning on or off the heater and cooler through the Blink IoT mobile app. As shown in the block diagram, you can understand that the temperature system provides the input to the Arduino Uno, and whatever temperature it gets is shown on the Blink IoT app as well as the CLCD. Now from the Blink IoT app, you can control the heater and the cooler, and this is again instructed by the Arduino Uno app to the temperature system. Now moving on to our final requirement, that was the water tank inlet and outlet valve to control the volume of the tank. We are to read the volume of the water tank in the water in the tank through serial communication and display it on the CLCD. Control the volume of the tank in the control the volume of water in the tank by controlling the inlet and outlet valve by sending commands through serial communication, and finally display the volume of the water in the tank on the CLC. For this, we wanted to automate the process of controlling the water level in the tanks, where you generally go physically switch on the valve and switch off the valve once the tank is full. Now, for automating this, what we have done is that if the tank's volume is less than 2000 or it falls below 2000, the inlet valve will open and water will start flowing so that it maintains the 2000 limit. And once the tank is full, it will switch off the inlet valve itself. For this, the water tank sends the data of the volume of water to Arduino Uno, which also displays it on the Blink IoT app as well as the CLCD. The Blink IoT app helps you control the inlet valve and the outlet valve, and this is instructed by the Arduino Uno to the water tank. These were the requirements that we have defined for our project, and we will be developing and coding the programs to control the same. For this, we have used two softwares, that is the PixemLab and the Blink IoT application. PixemLab is a real-time emulator of development boards, and this emulator we have used for emulating various widgets and devices, and especially the Arduino Uno board. With the help of this, we could connect the Arduino Uno board and widgets such as the temperature control system, the serial tank, and even the LEDs, and even the CLCD and LED lights. Blink IoT application is an IoT platform for iOS and Android smartphones that is used to control Arduino, Raspberry Pi, and Node MCU via the internet. This application is used to create a graphical interface or human machine interface by compiling and providing the appropriate address on the available widgets. We will be seeing the demo of the same in the future. Let's move on with the presentation. I have included a screenshot of the simulation that we have for our project. This is the actual simulation of our project. I'll explain what all is mentioned in what all is demonstrated in through the screenshot. Uh, with the help of Pixem Lab, we were able to emulate Arduino Uno board. As you can see, this is the Arduino Uno board. Now, Arduino Uno board the Pixem Lab also provides, along with this board, a few spare parts. Now, these spare parts include all the widgets that we have used throughout our project. This is the CLCD screen that will be used to display the temperature, the volume, and tell you if the heater or a cooler is on or off, or if the inlet valve or the outlet valve is on or off. Currently, it is not displaying the volume or the heater, cooler, or the inlet or output valve since the device is offline. We will see the online demonstration of the device future in the video. Now, this is the LDR sensor, light detection register. This is used to detect what is the light of the environment. With this scrolling button, you can control the light, and this will be outputted on this LED device. Now, this LED device, as you can see, is currently full because of LDR. It is showing its maximum brightness. Once you start scrolling it up and down, the brightness of this LED will vary. This is the temperature system, that is the LM35, that is embedded in this. This is the cooler, and the heater is also embedded. With the help of Arduino, we can control it with Blink IoT, whatever temperature you want to display. And this temperature will also be displayed on the CLCD. This is the serial remote tank that will be used for a third requirement, that is to emulate how an actual tank will be. The volume of the water currently is 0 because we have not connected it to the Arduino board currently. Well, once you connect, the inlet valve will open and the water will start flowing till you switch off the inlet valve or it reaches to the maximum limit. Once it reaches to the maximum capacity of 3000 liters, it will switch off the inlet valve itself. If you switch on the outlet valve, the volume will decrease till it reaches 2000, and after that the inlet valve will also begin. This was the simulation that we intend this was a simulation that we intend through our project, and we have implemented the same. Now, in conclusion, we have studied various concepts related to IoT and applied a project to simulate an application of the same. Blink application was used to provide an interface to control various widgets and devices. A home automation system was constructed, and we were able to meet all the requirements that were defined during the beginning of our internship. And finally, there was controlling all the widgets in real time through an emulation, and we were able to understand all the functionality of various widgets and microcontroller and all the applications that it has. This was all from my side, and thank you for listening to the presentation. We will now check out the demonstration of our actual project, starting off with the code that we have written for implementing all of the three requirements, that is controlling the garden lights, controlling the temperature system, and finally controlling the inlet and outlet valve to control the volume of water in the tank. This is the main code that is written in Arduino to connect all the three requirements with the actual widgets that are there on a Pixum lab. For this, we have written several functions, such as this function used to control the on and off buttons on the Blink IoT and turn the cooler on or off. This function is used to control the heater and turn it on or turn it off. Then this function is used to control the inlet button and turn it on or off. And finally, there is the outlet buttons function to control it and turn it on or off. Now we also have to update the temperature that we are reading on the temperature gauge. That is the current temperature that is demonstrated through the temperature system using the sensor is updated on the gauge and displayed on the application. The handle temp function is used to control whatever functionality we want to provide as an automation. Like for this, we have created a function where if the temperature increases more than 35, the heater will turn off itself and the notifications will be sent on the application. There is the function for the function handle tank that is used to provide a functionality where if the volume of the water falls below 2000, if it falls below 2000, the inlet valve will get turned on and there will be a flow of water inside. As well as if the tank's volume reaches 3000 liters, the inlet valve will turn off automatically. This was the setup function, and finally this was the loop function that runs again and again. Now all the three modules were also defined further. This is the LDR where the light sensor is, and for this we have initiated it through this function. The header file contains the variables and macros declared for this function. Main header file contains all the variables that are used throughout for each of our specific buttons of the application. Then there is the serial tank.cpp and serial tank.h that contain the header and macro as well as the functions to initiate this module. And finally, the third module, that was the temperature module, is initiated through this .cpp file as well as the .header file to declare the macros as well as the variables. This was all about the program that was written to control the project. Let's actually view a demonstration. This is the Pixum lab, and this is the Arduino board for the Pixum lab. Now to control, starting off the first requirement to control the garden lights, you can control it using the LDR sensor here. Currently it is at the brightest, so the output on the LED is also at its brightest. If you move the widget up and down, as you can see, the brightness also varies, where if you go towards the least, the brightness is at its least, and if you go on the top, the brightness is at its maximum. Moving on to the second requirement, that is the temperature requirement. For this, I will also show you I'll also mirror my mobile application of Blink. There are two buttons, that is the cooler and the heater button, as well as the temperature gauge, which demonstrates what is the current temperature, and the notification bar. Once you turn on the heater, as you can see, the temperature is rising, and once the temperature reaches at about 35, the heater will be turned on itself. We can also check out the functionality of the cooler, where as you can see the fan has started running and the temperature is also dropping. We'll turn off the we'll turn off the cooler and also check out the notification on the CLCD. There is the temperature and the cooler is turned off. Now we'll check out a third requirement, that was the serial tank automation. Now for serial tank automation, this is a serial tank which is connected. We currently we currently are not doing anything much. So let's switch on the inlet valve and let the water flow. Once the water level reaches at 3000, the inlet valve will get turned off automatically. And now let's check out the other functionality that we have provided. Let's switch on the outlet valve and let the water flow out. According to our code, if the water level reaches below 2000, the inlet valve will be turned on automatically. As you can see, the inlet valve has also turned on, trying to maintain the level at 2000. We'll turn off the outlet valve and also the inlet valve. The notifications for the same are also displayed here. As you can see, turning off the inlet valve, tank is full, turning off the inlet valve, tank is full, and even the part where if the water level was below 2000, turning on the inlet valve. These were all the notifications that were supposed to be put on the Blink IoT applications and have successfully been demonstrated. Also, the CLCD also shows you the notifications for the same, that is the current level of the tank and whether the what was the last command, that is the inlet valve was turned off. This was a demonstration for the home automation project, which met all of its requirements, that is controlling the garden lights, controlling the temperature system, as well as controlling the level or volume of water in the tank. Thank you for viewing this demonstration and have a great day.